Hello student, my name is Krishna and I'm a faculty of medicinal chemistry and I'm having 8 years of experience in teaching to 11th and 12th student. So this video on the P block element I'm going to give you because of your request. Some of my friends has requested to they want video lectures on P block. So guys, here we go. Without much wasting your time, we'll start with the lecture. This is a flow of presentation. This is an introductory lecture. So because what I decided to give you 10 minutes lecture so you can focus on the small parts. First part in this we're going to study the introduction of the periodic table, the periodic trends, electronic configurations is very important, and this from this 3 point definitely the question will be asked up to 3 to 4 marks. Guys, the scope of this chapter I'd like to share with you. This is scope CET. 2 to 3 question could be asked in NEET. 2 question could be asked for 8 marks. JEE one question. But for board exams, very important chapter because of almost 10 marks to 12 marks question could be asked. So this is a rank booster for you for sure. Guys, this is a periodic table. There are 118 element now. The periodic table is completed till date. Last year we added new 6 element. Guys, they are having a bunch of element, but our focus is on P block only. So we are not going to go in much of detail of this periodic table. This slide, guys, this is very important slide. This I kept purposefully because this is giving information about the size of atom. You can see the size of atom is increases down the line. The size is getting bigger and bigger as the cells are getting added. The first orbit, second orbit, as this increases, the size increases. But you can see from left to right, that is in a particularly a row, the size is getting reduced. The reason behind is because the nuclear charge is increases. As the nuclear charge increases, the attraction between the nucleus and the electron is increases, and the size decrease, the compression takes place. This is very important because if you know how the size increase or decrease, you can predict rest of the trends which are there in a periodic table. These are the different trends. There are so many trends, but only 10 which are important. So we'll focus on only 10 from which the question asks and which is there in your syllabus for 11th, 12th. These are the element. You can see the size is following the same trend, that is the increases from top to bottom and decreases from left to right. Yeah, these are the trends. So guys, there are, I chosen 10 important periodic trends, so from which the most likely question would be asked. First is atomic size, that already been discussed. The atomic size of element decreases from left to right and increases top to bottom. Now, there are next four, that is electron gain enthalpy, electropositivity, metallic character, and basic character. These four properties are directly proportional to size. Means, as the size decreases, this property also get decreases. As size increases, they also increases. So, we'll take one by one. Electron gain enthalpy, that is capacity or the tendency of element to receive electron. As the size is lesser, means what, electron, the orbital are very close to the nucleus and they can easily take electron, means no much energy will require to give electron to particular element. But if size is bigger size means what, the orbitals are far away from the nucleus and they don't feel any attraction, hence the tendency to lose the electron is more. But in this case, instead we want electron to be added to particular element, so this is opposite tendency, means we require much energy as element wants to lose and we want to feed the electron to particular element. So this is a controversial and conflict. So energy is much required when the size is bigger. So this follows this as size decreases, less energy, but size increases, more energies. Next is electropositivity. Electropositivity is a tendency to donate the electron. So if as I said, the more the size, more the tendency. If less the size, less the tendency to donate electron. So it follows the left to right, it decreases, and top to bottom it increases. Metallic character. Yes, metallic character means the few properties of metal, like it has a luster, it is a sonorous, it is it's ductile, malleable. So this property are directly proportional to size. If the size is bigger, the compound or the element would be shows metallic property. So example we can take, that is the any series that I will take one series, that is sodium, magnesium, the third row element: sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. So in this case you can see the size of sodium is bigger, so it is metallic in nature, but size of chlorine is smaller, so it is non-metallic in nature. Follows next basic character and acidic character. They are inversely proportional to each other. If the size is bigger, the basic character is more. The size is smaller, the acidic character is more. So the same example we'll take here. Sodium is bigger in size, so metallic character, as well as having basic property. But chlorine is smaller in size, so it is non-metallic as well as it is acidic in property. Next is very important, that is electronegativity. Electronegativity means capacity or tendency of a element to attract the electron pair of electron in a bonding, in any chemical bond. So the less the size, more the tendency. Means chlorine, fluorine, bromine having this all halogens having very good electronegativity. The most electronegative atom in the universe is fluorine, which is having a 4 unit as a electronegativity. So this is also inversely proportional to size. Now this all rest 5 properties, that is acidic character, electronegativity, non-metallic character, ionization energy, and electron affinity, are inversely proportional. Means the size decreases, this property will increases. So left to right size decreases, so opposite of that, this property will increases, the power increases, and the size top to bottom increases, but this property it decreases. So very simplistic, guys. One another property is very important, that is the ionization energy. Ionization energy is the very important definition, uh, because this could be asked so many times in an exam for MCQ, for 1 mark question. Ionization energy means the tendency or the energy required to remove one electron from gaseous state of the element. Remember here, the element should be in a gaseous state. If solid state of the element and we remove one electron, it is not ionization. For ionization, the element should be in a gaseous state only, and then only you can apply this definition. So a simple, the size is bigger, so more easily electron could be removed. So hence, more the size, very less energy is required. Lesser the size, more energy is required, because the now if less size is less, means the orbitals are close to the nucleus and their attraction is more. So more the attraction, more energy is required to break it. Means it's inversely proportional to size. So guys, next, this is a family of 3 scientists which has won the Nobel Prize. All of three of them has won a Nobel Prize. The purpose I put this picture, because she's Marie Curie, who invented or discovered the radioactivity phenomena, and also discovered 2 elements, that is radium and polonium. So polonium follow in a p-block element, so that's the reason I put this picture. Guys, next point is for electronic configuration, because one or two, definitely two questions will be there to write electronic configuration of any element from the periodic table. So this trend or this topic cover three chapters, that is S block, P block, D and F block. So any one of them could definitely ask to write electronic configuration. So guys, very simplistic. This is arranged according to above principle, means less the energy, faster the electron field. And as it goes 1s2, 2s2, 3s, so means what, the energy is increases as the orbital is away from the nucleus. Far away means having more energy, so this last orbital will be filled lastly. Sometimes this could be confusing because the sequence is like an flexible. After 4 years, 3D is filling. So this kind of trends could be very difficult to remember because the sequence is not in order. So for this, I have done one trick. So I like to share with you. So this school means for yes is the first orbit to be fill in, so we can take as a school to be remember. Next is school, so which school it is? This public school. So public school, which public school it is? So it is Delhi public school, because it's a, the words are spoken by the child, so it always speak two times. So Delhi public school. So when we go to school, then we find it is a faltu Delhi public school. So guys, by this I made this series. So now if you follow this, you will never ever get difficulty to write electronic configuration. So how to follow this? Because the S is following first orbit, P is there in second orbit, D is there in third orbit, and F in fourth orbit. So after first 1 years, the next S should be 2s. So we'll follow, and 2 years, 3 years, 4 years, all this will be get covered. 2p, up to 2p, the next P would be 3p only. After 3D, the next D would be 4D only. So likewise, you cover the S, P, D and F. So now this is completed. And this sequence has to be followed to fill the electron. Now guys, you can take any example. You put a name in periodic table. This sequence will help you to write electron configuration of any element. I once again repeat, few element which are exceptional, example copper, example chromium. Okay, so these are the few examples, gadolinium, which does not follow this very simple, could be variations due to stability of the orbital. So that will be taken separately because this is not a part of this chapter. But p block element follows this sequence of electronic configuration. P block element never violate these rules. So guys, next, start with the p block element introduction. What is the definition? Very simple definition: the element whose last electron, that is a differentiating electron, falls in a p orbital is called as a p block element. Guys, the background, you can see these orbitals. The p orbital actually is a dumbbell shaped. So according to the axis, the name differs. So x-axis is a px, y-axis py, and z-axis is a pz. If you compile this looks like this structure is like a flower. You can see at the corner. Yeah, this is the entire p block, guys. Six families are there: boron, carbon, nitrogen is also called as the nicogens, oxygen family, halogen family, and noble gas family. First, boron. In few, only 1 minute, like to share with the mnemonics for this p block. One is boron. Boron family is having mnemonic like बैंगन आलू गाजर in thali. नहीं? Now this UUT is tritium, which is now known as neonium. Okay, I will take it separately because these few elements which are added now, and we should know about them. Second is carbon family. Carbon family is very interesting mnemonic in Marathi actually. So it go like: कार्ट सायन्सला गेलं आणि सपाटून पडलं फुटलं. So carbon, silicon, germanium, tin, lead, and flerovium. This tin, that is Sn and Pb, are actually of the plumbing element, means the plumber is used to repair pipes. So Pb, plumbum, and Sn is stannum. Next is nitrogen family. Nitrogen family is go like नाना पाटेकर अच्छे से सब्जी बेचेगा मॉस्को में. So nitrogen, phosphorus, arsenic, antimony, bismuth, and moscovium. UUP is ununpentium. Ununpentium is now named as moscovium. Next is oxygen family. Oxygen, O Selena, sexy teri pose, lovely. Or it can also called as O Salman, Selena teri padosan, lovely. This polonium, which is discovered by Marie Curie, this already I have been shared with you. Next is a halogen family. Fluorine, chlorine, bromine, iodine, astatine. And this UUS is unseptium, which is now known as a tenacine. So guys, this sequence go like फिर कल बाहर आएगी आंटी टेरिस पे. Last, and this noble gas, these are the helium, Hina, Neha, or Karina ka X-ray rangin. Oh my God! So these are very beautiful ladies, actress. Whenever do X-ray, their X-ray is also rangin, colorful. They're so much beautiful. The X-ray become colorful. Usually the X-ray is black, right? So UUO is an octium. So it is now called as a ogneson. So why these names are there? So I will share with you. This is neonium first. The name is given because this is discovered by Japanese scientist, and Japan is named as a Nihon. So Nihonium. Moscovium actually is a laboratory placed in a Moscow. So this name is given by the city Moscow. Next is a flerovium. Flerovium is once again it's a laboratory which is there in Russia. But this laboratory is named after the scientist, physicist whose name is George Fleuriot. Next is livermorium. Livermorium is once again it's a laboratory is placed in California. So name is given after this laboratory because it's discovered in that particular lab. Tenacine. Tenacine is also place. Okay, so it is there in Russia. So another laboratory and another place. So the tenacin is name given by the place. Last is ogneson. Ogneson is name given by the scientist whose name is Yuri Ogneson. So is because he has contributed in discovering new element. So guys, we'll stop here, and in my next video I will share with you the trends in hydride, their reactions of particular hydrogen, oxygen, halogen with the family, this nitrogen family, and so on. And also we'll share the oxyacids of sulfur, phosphorus, which is very important, and also the interhalogen compounds. So guys, please, if you find this useful, like, share, and subscribe. Thank you.